Hello there. A really important skill today. Add by making 10. But first, can you complete this pattern? Pause the video to have a go. Did you spot the pattern? Excellent. If we place the number bonds like this, we can see how the number bonds are made. When we compare 9 to 10, we can see there's one gap. 9 plus 1 is equal to 10. What does 8 need? Plus 2. Number shapes are a really useful way of seeing the bonds to 10. We need to be really secure with our bonds to 10 in order to add efficiently. Making 10 is one of the most important strategies you'll learn. Here we have 8 plus 7. We could count on our fingers, but today we're thinking about efficient strategies, and counting on our fingers won't always be an efficient strategy. Here I have a 10 frame with 8 red counters and a 10 frame with 7 blue counters. When I'm making 10, I'm trying to fill up one of my 10 frames so it's full. So I'm going to take 2 blue counters and place them onto the red side and flip them over so that I've got 10 red counters. Now I can clearly see, instead of having 8 plus 7, I've made 10 plus 5. I haven't added any counters or taken any away. I've just moved 2 blue ones into the red 10 frame. And I've shown that 8 plus 7 is the same as, or equal to, 10 plus 5, which is a much easier calculation. Here we have another example. 5 plus 7. Remember, when we're making 10, we're trying to fill up one of our 10 frames. We can use our number bonds to help us. I've got 5 red counters, so I'll need 5 blue counters to fill up the 10 frame. Now I can clearly see I've got 10 and 2 more, which is a much easier calculation than 5 plus 7. I've put the counters back to how they originally were, 5 red counters and 7 blue counters. I'm going to show you another way of making 10. This time I'm going to take 3 red counters and place them onto the blue side. I've made 10 on the blue side and left 2 on the red side. Both strategies work perfectly well, and both show that 5 plus 7 is equal to 10 plus 2. It's all about making 10. Let's have a closer look at number bonds to 10. We've already seen how important they'll be when we're making 10. 10 plus 0 is my first bond, and here's my 10 frame. 10 red counters plus 0 yellow counters is equal to 10. The other bonds are going to appear. I'd like you to watch the counters and see how they change as each bond appears. With a partner, maybe you could have some red counters and your partner could have some yellow counters. You could place some red counters onto the 10 frame, and then your partner has to place the appropriate amount of yellow counters onto the 10 frame. Then you could record the bond that you've created. I wonder how you could record it to make sure that you wrote down all of the available bonds. Have fun and good luck. Earlier on, we saw that 5 plus 7 was equal to 12. We had 2 strategies for completing the problem. The first strategy, on the left, was to take the blue counters and place them onto the 10 frame with the red counters. Now what we were doing here was partitioning our 7 blue counters into a group of 5 and a group of 2. The group of 5 joined with the red counters to make 10, and the group of 2 stayed on their own, showing 10 plus 2. Our other example on the right hand side, we took the 3 red counters and placed them with the 7 blue counters. So we partitioned our 5 into 2 and 3. The 3 joined with the 7 blue counters to make 10, and the 2 red stayed where they were to show 10 plus 2. Which do you think is most efficient? In this example, I like the bond 5 plus 5, because I know 5 plus 5 makes 10. So I prefer the left-hand side. But it really is up to choice in this example. Let's have a look at some more and see which are most efficient. Here we have 6 plus 8. Let's partition the 8 first. Pause the video and think, what are we going to partition the 8 into? 8 and 0, 7 and 1, 6 and 2? Which are the best bonds to partition our 8 into? That's right, we need something to go with the 6 to make 10. 6 and 4 make 10. So we'll have to partition our 8 into 4 and 4. Now we can see 6 and 4 make 10, and then 10 plus 4 makes 14. That was a good method, wasn't it? What about if we partition the 6? Pause the video here and have a think. What do the 2 parts need to be? That's right. One of the parts needs to go with 8 to make 10. 8 and 2 makes 10. So therefore the other part must be 4, because 4 and 2 make 6. Now we can do 8 plus 2 is 10. And now we've got 10 and the 4 that's left over, making 14. Did you prefer the bond 6 plus 4 making 10, or 8 plus 2 making 10? Let's have a look at one more example. 9 plus 5. Pause the video here and have a go at partitioning the 5 so that the 9 and something can make 10, and then have a go at partitioning the 9 so that 5 and something can make 10. I wonder which you'll find easier. How did you do? Let's have a look through. Did you partition your 5 into 1 and 4 so that 9 plus 1 can make 10, and then 10 plus 4 makes 14? And when you partitioned your 9, did you make sure you had a 5 to go with the 5, and therefore the other part must be 4? Now 5 and 5 makes 10, and 10 plus 4 makes 14. Our final example is an interesting one to have a look at. When we partition our 5 into 4 and 1, it gives us 9 plus 1 as a bond to 10, which is quite an easy bond to 10, isn't it? Just 1 more than 9 is 10. But when we partition our 9 into 5 and 4, it gives us my favourite bond. 5 plus 5 is 10. So I think partitioning the 9 into 5 and 4 is the most efficient way for me on this one, because it includes my favourite bond. 5 plus 5 is 10. Which of the bonds today that we've used has been your favourite bond? Maybe it'll come up when you complete the worksheet.